Hi, everybody. I'm Tyler Morgan, and I'm really excited that we are joined today by Robin Heidemann, Rainer Goebel, and David Feinberg to give talks on kind of what a lot of us kind of think of as the three requirements that you really need in order to run fMRI experiments and layer-fMRI experiments. So you have someone that's working, well, multiple people that are working directly in hardware. And then we have sequence development experts as well as analysis methods and programming. So I'm going to start with Robin Heidemann, just to give an idea of how this will go. After each of the speakers, we'll have some time for like really brief questions, but we would really love that there's area for discussion after all three of the speakers have gone. So like I said, Robin Heidemann is joining us. He's the head of the ultra high field development and collaboration groups at Siemens Healthineers. Before he joined Siemens full time, he had an academic career combining image acceleration with very high resolution fMRI at Würzburg and Leipzig using 7T. And in collaborations with academia, Robin and his development group are developing, validating, and streamlining the usability of 7T scanners for research and for clinical use. In his presentation, he will talk about the vendor perspective of high resolution fMRI, and he will also tell us a bit about the Terra X system. So with that, Robin, take it away.
Thank you very much for the introduction, and thank you for having me here. It's a great pleasure on one hand side. On the other hand side, I have to say, when Renzo asked me if I should join the meeting, I was pretty much reluctant because the layer dinner is purely scientific, and I thought it would be not appropriate to give a marketing pitch there. But Renzo said I can do whatever I like. Okay, here I am. I promise you it's not a marketing pitch, and I will keep it short. I only have 10 slides because after me we have fantastic speaker, Rainer and David. They really have the cool stories to tell you. I will have a little bit update on Terra X, not so much on high resolution fMRI, I have to tell you, because we discussed this just briefly. The Terra X currently is mainly in clinical settings, and I don't know if there's any research setting really is running high resolution fMRI on a Terra X. Anyhow, I would like to talk about Terra X, and I start with the fancy marketing title, Make the Difference. And you may immediately ask yourself why. And here's my little answer. And this answer is mainly driven, of course, by the clinical need. So make the difference for the benefit of patients. And this means for those of you who observe the field, maybe not really work in the clinical arena, but you observe the field, you see that there is more and more publication coming up, more and more evidence that 7T really offers some unique features, some unique benefits for patients. Epilepsy is maybe the most prominent one where the resolution really counts, but also there's more and more publications with MS, for example. You may know that the central vein sign is now a sign for MS, and if in more than 30% of the lesions which you find, you see a central vein sign, then it is MS. At 7T, people now really see that all MS lesions, nearly all MS lesions show the central vein sign. At 3T, maybe you can have cases where only a few show it and some not. At 7T, if it's MS, more or less every lesion shows the central vein sign. So it really becomes a clear marker for this disease. And there was one thing. We started with the Magentom Terra in 2017 as a first clinical 7T system. But very clearly, the community told us if 7T should further progress in the clinical world, you need to make PTX clinical. It's a prerequisite. It's mandatory. And now looking back where actually PTX comes from, PTX was delivered to the systems, and the systems at that time point were a pure research system in neuro research sites. And they were asking for such a technology. And now I tell a little bit of the history, and I hope nobody will record this, because what we delivered in that time point was really, let's call it a green banana. The Terra X, the PTX system, step one, was just a set of toys for researchers. It was never meant to become a product which would be used then in the clinical environment. We improved step by step. So there was a PTX step 1, step 2, 2.2, 2.3. It became better and better, but it was still far away of being really integrated and useful for clinicians. With Terra, we had the research mode. It was fully integrated. It became better and better, but it was not yet clinically approved. With Terra X, it will be. And now I have to distinguish between US and the rest of the world. In Europe, it is clinically approved. We have the CE authorization to market. In the US, we have 510K pending. But the thing is, it will come. I'm really confident. And I would like to talk a little bit about PTX in a few seconds. The other big pillar of innovation, which is important for a new 7T system, is deep learning. Nobody can come around it. At the beginning, we thought deep learning, fancy stuff. Is it really paying off? I will show you a slide. Yes, it will. A funny anecdote, during our Bamberg meeting in 2019, we asked the community, hey, what do you think about deep learning and 7T? And it was, I always say, the most unexcited audience I've ever seen, because everybody was saying, yes, clear, it will come. And yes, 7T will also benefit from it. It was a fact. It was not an excitement anymore. Okay, people obviously are cooler than we are. And the other application, which is not so interesting maybe for you, clinical applications, new clinical applications to really enable the 7T to be useful in a broad clinical use. So the slide which is coming, I promise you, will become ugly. So this is why I will build it up step by step. It's just a huge list of features. I try to highlight those which are maybe for you more interesting. PTX, I already talked a lot about it. What's new when you compare Terra X to Terra? Improved SAR performance. Does not sound very spectacular, but I can tell you, this is 2 years hard work at Siemens and at Nova Medical to come up with a complete new SAR supervision. Complete new SAR supervision means a new VOP file, the virtual observation point file. As you may know, that's a core component of PTX, of the SAR supervision of PTX. And new way how to calculate and detect SAR. And this gives us now a performance increase of the Terra X PTX compared to Terra of a factor of 2 to 4. And that was actually a mandatory step, because if you have experience on the Terra, when you switch from the clinical approved single channel mode to the PTX mode, you lose a factor of 2 in performance. For a clinical use, this would be a showstopper. So it was clear we have to come to at least the same performance as on the single channel system. And now we have reached this and even above. So again, 2 to 4 improvement. That's really amazing. And it's the opening that you can also run then high energy sequences like the TSE, which radiologists really like. Individual optimized RF pulses. So the PTX pulses are really individually optimized on the person who is in the scanner. That's super important in the clinical setting, maybe not so much when you scan healthy volunteers, because you can expect that healthy volunteers have a normal brain. In the clinical case, you may have really big pathologies, liquid-filled cyst, which can be easily of 5 or even more centimeters in diameter. And these kind of pathologies would result in suboptimal PTX pulses if you would use a kind of generalized pulse, for example. And we have also now shown in their publication showing that individual pulses are really also important in this case. Dynamic PTX, this means that you have really full PTX capabilities. So have time varying amplitude, phases, and gradients during the RF. That's in the first run implemented only for the turboflash sequence. The most important variant here in the clinic is MP-RAGE, MP2-RAGE. But we will come up soon with more sequences from the clinicians. Of course, the space is super important. This will come for you. It's more the EPI and maybe also the 3D EPI sequence, which is of interest for you if you go more towards fMRI or structural. So these things are ongoing, and I really hope that within the next, I mean, for you as a researchers, it will come way earlier, but for the clinicians, I would say roughly 1.5 years from now, we will have another set of clinical approved sequences then available. But as a work in progress package, these things will come earlier. Okay, acceleration everything is there. You already have it on the Terra or partly on the Terra as a work in progress package. Now all these things are clinical approved. Deep learning is now completely new on Terra X. The deep resolve boost, I have not highlighted it, but maybe just for your explanation, this is really a case-based to image reconstruction. And the network is trained on 7T data. So it has seen really the structures which are able to acquire at 7T, which is really important. And I will show you an example later on that this is really doing a great job. Deep RXE, that's a bias field correction. And that's maybe interesting. If you correct the transmit inhomogeneities by PTX, then the receive inhomogeneities will be even more pronounced than it has been before because they partially compensate out. So you have to do something against the bias field, otherwise you would have another issue. So you correct the transmit field, but the receive field is then the problem. So in combination, PTX with the bias field correction, deep RXE gives you then a really a homogeneous appearance of the image. The clinical applications, there are a lot of new applications, new for 7T. I mean, Dixon is already approved at 1.5 and 3T for quite a while, but we have now the TSE Dixon or Blade and stuff like this brought to this clinical scope. Important stuff for you, that's the physiologging. That's something which is really nice because you have just a check mark and then the physio data is written into a non-DICOM format into the DICOM database. So this means you can just use a DICOM to get the physio data out of it, as you may have the same functionality with some C2Ps, like I think Minnesota also have this. The Minnesota C2P is using also this kind of format because in our former systems, we wrote the physio data, but it was an ASCII file. And that's somehow inconvenient, or the pipeline was not optimized for this, and they expect DICOM. So now you have a DICOM data, but the information is the physio data. So non-DICOM data in a DICOM format. That's the right way. Open Recon is also interesting for you because this enables you to do your own reconstructions on the scanner without violating the CE or clinical approval if it's there in the US. What does it mean? You have an output thing that you can pass raw data into a container. And in this container, you can do whatever you like. You can have your own Python code, MATLAB code, you name it. And then you can reject the images back into the image pipeline. So currently we only have the 2 points. You can dig out the raw data, the tricks data more or less, and you can re-inject the images. But in the future, it's planned to have more stages to get the data out, maybe after phase correction or after whatever that you have, like in the Fire whip. If you know this whip, in Fire, you have more or less more options to get the data. And the Open Recon is a product implementation of the Fire whip, which again enables you can do your own post-processing on the Mars computer without violating the clinical approval. And finally, some new hardware is also coming. Mars and host computer is, of course, super important because a lot of data always needs a lot of computational power. Reduced number of cabinets I write down to make the point, what is the big difference between Terra and Terra X? On Terra, we had this 2-channel idea that we have a single channel system and a parallel transmit system. The one is partly clinical approved, the single channel system, and the PTX system is pure research. This is no longer the case. The Terra X is a pure PTX system. There is no single channel system anymore there. And so this means all the electronics for the single channel part is kicked out, and this allows us to reduce the number of cabinets. However, if you have single channel coils, which you would like to use on the Terra X, there is a combiner at the patient table end. And if you plug the combiner, you can just use all the TIM plugs as you are used to use it on the Terra. Okay, and now this was the ugly slide. I hope now come more nicer slides. And just going back to PTX, this is our beloved marketing slide, which we always show to tell people what PTX can do. Remember, it's a NOVA head coil, and the NOVA head coil is a brain coil, but you can see the complete brain. You see the cerebellum nicely. You see the brainstem. You can even see into the C-spine, and I would say up to C3. There's sufficient signal to even say it's diagnostic. And if you look on the very right hand, you even see the beginning of the shoulders. Amazing. But some of you may realize, hey, that's a pretty small head with a very long neck. It's a marketing brain. It's not me. We have more marketing brains at Siemens. But the thing is, with a small head size, the problems at 7T are not so extreme. And even without PTX, maybe we would see the nice cerebellum. We would not see the brainstem so nicely and the C-spine, but the cerebellum would be fine. And the big question is this also working in a clinical setting where I can select only volunteers which have a very long neck and a small head, where I have to scan actually every patient which comes to the table. And this shows you, yes, it's obviously a person with a pretty large head. It's an elderly patient. You see a very short neck, very strong neck. It's an absolute worst case scenario for 7T. And when you look close, even in the occipital lobe, you see signal voids, which is pretty rare. Normally, we only see it in the cerebellum, maybe a little bit in the frontal part. C-spine, we never see, but the occipital lobe, that's pretty rare that it's affected. And with PTX, with full dynamic PTX, the signal is really recovered everywhere. That's fully clinical diagnostic, even down slightly in the C-spine. It's not complete, so I will never say that this is a C-spine coil. It's a brain coil, and we can start to look into the C-spine. Here's another example. Again, a person with a pretty large head, short, strong neck. But you see everywhere, it's nice. Clinically, it's absolutely acceptable and diagnostic. But here I would like to point your attention to the acquisition time, 3 minutes, 0.8 millimeter isotropic resolution in 3 minutes. With this quality, I would say that's really good for clinical usage. So this is really what was necessary to make this case really full acceptable in clinical world, for example, for epilepsy scanning, because people often look in the temporal lobes, and the temporal lobes was the region where we see from time to time issues at 7T when we have big heads. And now I come briefly to the deep resolve stuff, to the deep learning things. This is TSE, T2 TSE. And on the left-hand side, it's a acceleration factor of 2 acquired or reconstructed with our product implementation of Grappa. And on the right-hand side, you see a factor of 4 acceleration reconstructed with deep resolve boost. So it's 50% faster. And if you look closely, especially on the upper left part of the brain, when you look to the perivascular spaces, you can see that these little details are even sharper at the deep resolve image compared to the Grappa image, because the Grappa image has already a little bit too much noise and may overlay these things. And that's the important thing. The deep learning network needs to see these tiny structures. It's not a network which can create something. It's only a network which takes away noise. However, if the network would never have seen fine structures, it can then also take away a little bit of the structure, because it may believe it's noise. So this is why we really insist it's necessary to train data with a resolution which is then really used for the reconstruction. And now I'm close to the end already. And just, I know it's a little stupid idea, but there is another layer community. As you may know, cartilage is also organized in layers. And funnily, there's also a radial structured in the cartilage. If you look very closely, you see the radial organization in the cartilage. Not similar, but let's say in the cortex, you also know there's a radial fractional anisotropy in the brain. The interesting thing I want to make, it's not all these things besides PTX. This is single channel. Also, MSK benefits now from the development on Terra X, and these super fine structures. And I would like to highlight here that the articular cartilage can also be nicely depicted here in the tibiofibular joint. This is a little one on which I have enlarged, and that's really a tiny structure. So MSK radiologists were really pleased to see this. And now I promise, to my really last slide, that the community here makes the difference and drive the field. And that was Renzo said, and that's a funny or interesting thing, or the great thing, that this community is not just one homogeneous group. There are different people with different focuses and strengths. And it might be, at 7T, we started pure neuro research. Then the clinicians somehow get more and more involved and push the fields towards a more robust clinical implementation like the PTX. And now I hope really that the neuro folks can benefit from this, because if the PTX is fully integrated and is just working, you can then focus and concentrate your work on new research. And now then I'm waiting for what comes next. PTX was in the past, and now we have it clinical. What is the next thing you really need, and which then maybe is taken by the clinicians, and then we will be asked again to make it clinical. So thank you for being active, and I'm really looking forward to discuss with you things, and because that's really the essence of how we can drive the field. Thank you.